Hello student, how are you all? I hope you all are well. So this is your educator Haraprasad. So today we are going to start a very interesting topic and it is the easy topic and most of the questions are coming directly from this topic. Okay, so in your BSc, MEC, it is going to play a very important role in the legislature. Let's understand this topic carefully. So what do we mean by this word first? Let me talk about that. What do we mean by this one? The laser. What does it stand for? Let's understand this thoroughly. So first of all, this L stands for your light, okay, and A stands for your for amplitude, amplification, not amplitude. It stands for amplification, and S is your stimulated light amplification by stimulated emission radiation. Okay, stimulation. Then this is the emission, and the last one R stands for radiation. So before the leisure, the thing come into picture is the measure. Okay, measure is the first one was introduced by your. If I am not wrong, please correct me if I am wrong. In 1958, I guess the thing measure was discovered. Okay, I didn't. So uh, basically 1954 or 1958. You have to check your book for that. Okay, clear. Actually, uh, what do it stands for? Actually, you have to read light matter interaction. Light matter interaction. So tell me, what do you mean by light matter interaction? That means when I am talking about the light matter interaction, that stands for atom. You know, atom has discrete energy levels, isn't it? Discrete energy levels. Okay. And one more thing you have to Uh, remember that when light interacts with matter, what happens? There are three possibilities. Mainly, there are three possibilities. What are these possibilities? The possibilities are like what will happen? Either absorption will happen, absorption. Okay. Second one is spontaneous emission, spontaneous emission. The third one is stimulated emission. The word spontaneous, stimulated, these are very, very important things. And they are going to play a huge role in the understanding this topic later. Stimulated emission. Okay. So let me go deep into this. But what do we mean by stimulated absorption? Let us understand this. Stimulated absorption. Okay. Let me draw two energy levels. Let me draw these. So I hope you can understand. These are two energy level E1 and E2. Okay. When my photon will come like this, H nu. Okay. So what happens if we draw it? E1 and E2. Lotus negative E1, lotus negative. So this is for stimulated absorption. So let's suppose this is H nu, the energy of the photon, and what happens if my particle is here, the electron is here. So the photon will bombard with this and it will get excited and this one is a before picture, so the after picture will be how much, will look like this will be your E1, this will be your E2, and the after picture will be like this. Okay, it will jump by taking the energy of the photon and it will jump to the higher level, that is E2. Here remember, E2 is greater than E1. E2 is greater than E1. Remember this. Atom initially, how does it say? Understand this. Atom initially in ground state, okay, and it absorbs light and rises to higher energy level. It absorbs light and rises or jumps to higher energy levels. Okay. So my energy difference will be how much? H nu is equal to E2 minus E1. Clear? Everyone? Clear? This thing is clear now. So this H nu, what does it stand for? This H nu is your energy of photon, as I have told you, energy of photon or light, we can say, and this is the energy difference between two energy levels. So first one is gone, that is stimulated absorption. Let us go to the second thing. The second thing is your spontaneous emission, isn't it? Spontaneous emission. Spontaneous emission. You have to understand what do we mean by spontaneous emission. So let me draw the scenario. What does it happen? Like this. Before picture and the after picture. You have to draw the two things. Before picture. So for before picture, you need to understand there are two energy levels. This is E2, this is E1. Okay. So my atom is here before in the higher energy level state. So spontaneously it emits, emission happens. So after picture will be like this. After emitting, how do it emit and come to the lower energy state? As we all know in atomic physics or in quantum mechanics, we know whenever there is a transition happens, so it emits certain energy or it requires certain energy or it absorbs certain energy to go to the higher state and it emits certain energy to come to the lower state. So here, as my spontaneous emission is happening, so it will emit certain energy and it will come to the lower state, that is E1, and it emit actually it emits a photon H. Okay, so some more information about this. Atom is excited atom in excited state. Atom in excited state has very small lifetime, has very small lifetime. So what is that lifetime? That is 10 to the power minus 8 seconds. It decays to ground state spontaneously. It decays to ground state spontaneously. So by emitting a photon, that is H is equal to, sorry, the frequency, na? You have to find out the frequency. How much frequency it will emit. E2 minus E1 divided by H. Radiation emitted by each atom goes randomly in any direction. So the radiation which emitted by the atom can be gone in any direction. Radiation emitted by spontaneous emission is incoherent. Remember this thing. That is radiation emitted by spontaneous emission is incoherent in nature. Incoherent. Incoherent. In optics, you have heard about this word. Okay, incoherent in nature, aren't you? So there is a small mistake. Only single H will be there. Incoherent. Okay. Incoherent double R. Okay, let me erase it. Incoherent in nature. So this is all about your spontaneous emission. Let us come to the next. That is the third one. Is a stimulated emission. What do we mean by stimulated emission? Let's understand this stimulated emission. So the scenario will be like this. This is the before picture. This is the after picture. Always try to understand the concept hidden behind the story. You have to understand those concepts. That's the very important or very pioneer thing in physics. You need to learn that. So before my atom will be in higher state as it will emit energy, and here the thing we need a exciter. Exciter means we need, like we tell we in chemical reaction we need a reagent to do the reaction, to do the reaction and get the product. Like here is this similar scenario. We need to certain we need certain things, like here particularly we need the photon. We need a photon energy or light particle to stimulate my atom to go to the lower state, to stimulate my electron to go to the next lower state, that is H nu. Here, this is the before scenario. The after scenario will be like this. This is my E1, E2, and H nu. Two photons will be released. This is after scenario is my electron will be like here. My electron will be here. This is the after scenario. So what happened here is, and here the photon is in same direction. The radiation here will be in same direction. Remember this one, same direction. The emission will be in same direction. Remember this. Remember, the emission will be in same direction. Okay. The next thing you need to understand so actually what happens in stimulator emission. Atoms in excited state under the influence of incident radiation decays to lower energy level and emits radiation of same frequency of incident photon. Here the radiation emitted has same frequency. Clear? Okay, so auto text has been off. Sorry for that. Okay. So the photon has same frequency. Clear? The two emitted photons, one is the incident photons and another is the emitted photon, have same frequency. Direction of propagation, energy, phase, and state of polarization of emitted photon is exactly same as the incident photon. So you can say it seems like the two photons are emitted, the radiations are emitted from a coherent source. We can say. Okay. So we can say in case of a spontaneous emission, the radiation emitted is incoherent. I have mentioned there. And here the radiation emitted is coherent. Why we are saying it coherent? Because what happened is, why we are saying it coherent? Because the phase, the phase state of polarization, everything is same. Everything is same as the incident and emitted photon has same frequency, same state of polarization. That's why we are saying those are coherent. Those are coming from a coherent source. And the stimulated emission results in amplification of light. The more important thing is here to remember is the stimulated emission results in amplification of light. Yeah, amplification. So this is for today's class. In the next class, I will be talking about the next phenomena related to your leisure. We will talk about the Einstein's coefficients, okay, and some mathematical calculations are there. We will do some basic problems, and your lecture will be complete. So for today, this is all for you. Thank you. Do like and subscribe.